ओके। तो पिछली क्लास में पार्ट 1 हम लोग इस रेजोल्यूशन तक पढ़े थे रिमोट सेंसिंग में। आज रेजोल्यूशन से थोड़ा सा आगे बढ़ चलते हैं और वी आर स्टार्टिंग फ्रॉम द स्पेक्ट्रल रेजोल्यूशन। ये भी क्लास काफ़ी लंबा होने वाला है। और यार सब वीडियो शुरू करने से पहले एक ये कहना चाहता हूँ कि प्लीज़ लाइक और शेयर इस वीडियो को कर दो, कम से कम शेयर नहीं तो लाइक कर दो, ताकि इसका एल्गोरिथम ये है कि आगे तक वीडियो को पहुँचे और लोगों को इसका लाभ मिले। ओके, विदाउट वेस्टिंग द टाइम वी आर गोइंग टू लेक्चर वीडियो। चलिए स्टार्ट करते हैं। यहाँ से वो ले लेते हैं हाइलाइटर्स। Now starting with spectral resolution. Spectral resolution describes the ability of a sensor to define the wavelength of intervals. The finer the spectral resolution, the narrower the wavelength range for a particular change or wind. Black and white film records wavelength extending over much or all the visible portion of the electromagnetic spectrum. Its spectral resolution is fairly coarse, as the various wavelengths of the visible spectrum are not individually distinguished, and the overall reflectance in entire visible portion is recorded. Color film is also sensitive to the reflected energy over the visible portion of the spectrum, but has higher spectral resolution as it's individually sensitive to reflected energy at the blue, green, and red wavelength of the spectrum. Thus, it can represent features of various colors based on their reflectance in each of these distinct wavelengths ranges. Many remote sensing systems record energy over several separate wavelength ranges at various spectral resolution. So, spectral resolution depends on their electromagnetic radiation that we have seen in the first part of this video. Hope you all have well understood. Radiometric resolution. Radiometric characteristics describe the actual information central content in an image. Every time an image is acquired on or by a sensor, its sensitivity to the magnitude of the electromagnetic energy determines the radiometric resolution. The radiometric resolution of an imaging system describes its ability to discriminate every silent differences in energy. The finer radiometric resolution of a sensor, the more sensitive it is to detecting small differences in reflected or emitted energy. Imaginary data are represented by positive digital numbers, which vary from 0 to or a selected power of 2, or which less than 1. This range correspond to the number of bits used for corresponding number in a binary format. Each bit records an exponent of power 2. 1 bit is equal to 20 to the power 1. अच्छा, ये जो आपका लैपटॉप और समथिंग्स अगर पीसी है, उस पर जब आप उसके प्रॉपर्टी पीसी पे चेक करते हैं तो 32 बिट्स और 64 बिट्स लिखा रहता है. व्हाट इज द मीनिंग ऑफ दिस? It means that in a 32 second they are passing the information in every each second. 64 bit means in 64 times they passing the information. The maximum number of brightness levels available depends on the number of bits used in representing the energy recorded. Thus, if a sensor used 8 bits to record the data, there would be 2 to the power 8 to 56 digital values available ranging from 0 to 255. These are the different pixel values. 0 to 55, 0 is a light, it will be the maximum darkness, and is in a pixel palette form. Thermal resolution. Thermal resolution is also important to consider in a remote sensing system, which refers to the length of time it takes for a satellite to complete one entire orbit cycle. The revisit period of a satellite sensor is usually several days. Therefore, the absolute temporal resolution of a remote sensing system to image the exact same area at the same viewing angle a second time is equal to this period. These are some satellite, Landsat satellite, which multispectrum band MSS launch in March 85. India is what was altitude 780 meter resolution, and its pixel size 30 meter. Thematic map, enhanced thematic map per band 1234, and now the latest version, the panchromatic enhanced thematic matter map plus, that is the 15 meter, which work is the Google images, that's Google satellite images on Landsat ETM plus panchromatic 15 meter resolution. SPOT, Satellite for Observation de la Terra. SPOT is the European Earth Observing Satellite System. The SPOT satellites operates from a synchronous near polar orbit 832 km above the Earth. Each nominal scenes covers a 60 by 60 meter, 37 by 37 square mile area. Sensor characteristics: mode multispectrum, band 123, resolution 20 meter, 20 meter, 20 meter. Obviously 20 meter is band 123. Panchromatic is at 10 meter. Mode band micrometer, multispectrum 0.5, 0.9 and 0.61, 0.9. Panchromatic 0.51, 51 micrometer. IRS, that is a technical summary of the IRS satellites. IRS-1C launch 28 December 95 and IRS ID 29 September 1997. Altitude 817 km. Second is 872, 824 km. Inclination 96.9, 98.69, 98.653 degree. Crystal orbit cycle is 341, 350. 2 is 8 is for second one. Revisit 24 days, 25 days. Sensor pan list 2 Wi-Fi and for second IRS ID. Pan list third Wi-Fi. Band 1 for panchromatic and WS bandwidth 5.8 meter resolution pixel size and 188 meter pixel size. Similarly for band micrometers in the green red in the visible range to the near infrared, that is the 23 and 80 meter. Cartosat-1 launched date May 2005. Launch location Sriharikota, India. Nominal altitude 618 km. Orbits per day 15. Orbital repeat cycle 116 days. Node for P/L operator, descending node, and local time for equatorial crossing inclination 10:30 am, 97.8. Resolution for the pixel 2.4 4 camera, payload camera, after camera 2.4 meter resolution. Overall resolution Shat kilometer is what is the size I have told you, 30 km to 36.8. Ground image size is 26.30. Overlap is 1.3 and side lap is 1.5 per second for the 5.3. Cartosat 2 satellite feature: orbit is circular polar synchronous. Orbit height 635 km. Orbit inclination 97.9 degree. Orbit period 97.4 minutes. And altitude, overall altitude is 635 km. Local time 9:30 am. Repeatedly 310 days. Revisit 4 days. Lift of mass 680 kg. Attitude orbit control 3 axis stabilized using high torque reaction wheels, magnetic torques and horizontal thrusters. Electrical power 900 watt to 18 nickel cadmium batteries. Mission life 5 years. Payload pan camera and panchromatic camera, geometric and the field of view and 1 meter is the pixel resolution. Spectral band is this micron. Or solid state recorder 64 GB capacity for image data storage. Hyderabad part 2, that is the 1 meter resolution. It is 1 meter resolution. Econos satellite launched 24 September 1999 USA. Operational life 7 years. Orbit this degree. Speed of orbit 7.5 kilometer. Speed over the ground 6.8 kilometer. Number of revolution around the Earth 14.7 every 24 hours. Orbit time around the Earth 98 minutes. Altitude 681 kilometers. Resolution is 0.82 meter and 3.2 meter of Nadir and Nadir. Image swath is 11.3 km at Nadir and 13.9 km at 26 of Nadir. Equator crossing time normally 10:30 am solar time. Revisit time approximately 30 days at 40 days. Dynamic range 11 bits per pixel. Image band panchromatic blue, green, red, and near infrared. You can select image Vatican City. That is 0.82 and 3.2 meter. Its pixel resolution. So you can see how the pixel images are very clear from this satellite. Kuiper satellites launched date 18 October 2001, Vandenberg Air Force Base, California. Orbit 450 km altitude, 93.5 minutes. Orbit time 10:30 am. Equator crossing time. Normal swath width 16.5 km at Nadir and total 450 km altitudes. Resolution 0.61 meter. Spectral band 450 to 900 nanometer. Basic 0.61 meter at Nadir and 0.72 meter at 25 degree of Nadir. Standard and over rectified resemble a to 0.6 that is multispectral band is basic 2.1 meters at Nadir, and these are the blue and this is the range for the infrared visible range and near infrared, and the 0.61 meter is the resolution. Kuiper satellite image Paris part 2. You can see the very clear picture from the Kuiper satellites. GeoEye-1 Satellite camera modes simultaneously panchromatic and multispectral, pan-sharpened, panchromatic only, multispectral only. Resolution 0.41 मीटर, इसका मतलब इसका पिक्चर क्वालिटी और अच्छा होने वाला है. 0.1 मीटर पैनक्रोमेटिक नॉमिनल एट नादिर पॉइंट, 1.65 मीटर मल्टीस्पेक्ट्रल नॉमिनल एट नादिर. Swath width and representative area. Nominal swath width 15.2 kilometer with 9.44 mile at Nadir. Single points into 25 square kilometer, 15 multiplied by 15. Daily monoscopic area up to 7 lakh square kilometer per day of pan area, up to 3 lakh 57 square kilometer per day of pan certain multispectral area. Orbital altitude is 684 kilometer. It means that is in synchronous satellite. Inclination equator is crossing time 98 degrees. Orbit type Pearson synchronous 98 minutes. Launch date September 6, 2008. Pentagon Memorial, Washington DC. This is the picture quality of the GeoEye Satellite 1. Colors, and this also from the Geo Satellite 1. Satellite 1. Color and color space. This topic is very important. The characteristic of the color: hue, brightness, the luminance of an object, saturation, the blue sky. The wavelength of light, relative sensitivity: blue, cyan, green, and red. Blue, it is a cube for the color color pattern. That is the blue 001, magenta 101. This I have to take a separate class for this to understand this color pattern. Simply just see this is a color cube for the three major blue, magenta, black, red, yellow, green, white, cyan. This is the hexagonal brightness, saturation, and this is the hue. Notation is the hue, and that points here. Color space RGB, the simplest color space. Access red, green, blue. Advantage simple. Additive color mixing, the mixing of light. Primary red, green, blue. The complementary color white means. Subtractive color mixing, the mixing of pigment. Primary color cyan and magenta yellow. The complementary color is that is the part of the separate video. And Newton color circle, just see this is the Newton color circle. Newton color circle tool to predict color mixing, use and saturation. Color space used for printing. Use the subtractive color mixing as a cyan, magenta, yellow, a black. Color conservation from RGB, that is a cyan, magenta, yellow, and CMY. Color space comparison, color RGB, additive color subtractive used for this is used for the printer, cyan, magenta, yellow, black, was in pigment mixing. Color components, real color compositing, red band on red, green band on green, blue band on blue. Color composites, red color composites, red band on red, green band on green. Real true color composites, red band on red, green band on green, blue band on blue. Approximation to real true color. False color composite, near infrared band on red, red band on green, and green band on blue. And this is the false color composite, is very important. When the visible range is replaced by the near infrared in red color, and red band is replaced by on green, and green band is replaced by blue, this is a false color composite. Digital image processing. Now, what is the image processing? It is enhancing an image or extracting information or features from an imaging. Computerized routines for information extraction, example pattern recognition, classification from remotely sensed image to obtain categories of information about specific features. Image quality and statistical evaluation, it's also part of image processing, includes radiometric correction, geometric correction, image enhancement and sharpening, image classification, pixel based and object oriented based, accuracy assessment of classification, post classification and GIS change detection. Okay, remote sensing raster data format, digital number of column 5, it is the 5 column, these are the column 5, row 4 and band 2 is expressed as BV54105. Where is the 105? This is the column 5, row 4, 1, 2, 3, 4, and band 2, and this is the band 2, that is the 105 here, this one. Image file formats, there are 3 types of image file format. The first is the band sequential format. Each line of data followed immediately by the next line in the same spectral band. This format is optimal for spatial XY access of any part of a single spectral band, good for multispectral images. BIP, band interval by pixel format. The first pixel for all bands in sequential order, followed by the second pixel for all bands, followed by the third pixel for all bands, etc. Leave up to the number of pixels. This format provides optimum operation of the spectral z direction access of the image data, good for the hyperspectral images. And what is the BIL, band interleaved by line format. The first line of the first band followed by the first line of the second band followed by the first line of the third band, interleaved up to the number of bands. Subsequent lines of the each band are interleaved in a similar fashion. These formats provide a compromise in performance between spatial and spectral processing, and is the recommended the format for the most in-B processing tasks, good for images with the 2 to 60 bands. Then अगर फिर से देखें तो BSQ क्या बैंड सिक्वेंशियल फॉर्मेशन है. BIP, BSQ is very good for the multispectral images. BIP is a band interleaved by pixel format. It is good for the hyperspectral images. And BIL is the band interleaved by the line format and good for images with the 20 to 60 bands. Just see the band 2, band 3 and band 4 and BIL format, and this is the BSQ format, and this is the BIP format for this image classification, and these are the uh, band matrix of the pixels, and this is the image format of the tree. This what is this ये आप इसको ध्यान से देखिए, इसमें किस तरीके से इमेज का फॉर्मेट किया है। ये एक सिंपल तरीके से इसे आप समझ जाएंगे, पास करके आप इसे देख सकते हैं। फिर देखते हैं band sequential BSQ format store information for the image one band at a time. In other words, data for all pixel for band 1 is stored first, the data for all pixel for band 2, and so on. Value image CRB rows 1 band 1, that is the format for the image storage in the BSQ format, band sequential format. Band interleaved by pixel BIP data is similar to BIL data, except that the data for each pixel is written band by band. For example, within the same 3 band image, data for bands 1, 2 and 3 are written for the first pixel in column 1, the data for bands 1, 2 and 3 are written for the first pixel in column 2, and so on. Just see for the BIP value is the BCR. Third is the band interleaved by line. Data stores pixel information band by band for each given a 3 band image. All 3 bands of data are written for a row 1, all 3 bands of the data are written for row 2, and so on until the data number of the total number of rows in the image is reached. Value is a CBR. अब बात करें तो इमेज एक्विजिशन, इमेज प्रोसेसिंग, फीचर एक्सट्रैक्शन, इमेज क्लासिफिकेशन, देन एक्यूरेसी असेसमेंट, इमेज क्वालिटी क्या होता है देखते हैं. Many remote sensing data sets contain high quality accurate data. Unfortunately, sometimes error or noise is introduced in remote sensing data. The environment example, atmospheric scattering cloud, random or systematic malfunction of the remote sensing system example, and uncalibrated detector creators stripping or improper processing of the remote sensor data due to the actual data analysis example, inaccurate analog to digital conversion. देखते हैं ये थोड़ा सा mean median mode central tendency of the univariate descriptive image statistic. The mode is the value that occurs the most frequently in a distribution and is usually the highest point of the histogram. It is common to the and that is the mode in 2 mode is a script data, and the mean of this here you know the central tendency of the any data set and the image property of this minimum variance skewness. You know about these things. These are part of the statistics and how to calculate the image GIS. In GIS, how to calculate the statistics of the image. These are the property. You know about the normal distribution function. Here is the mean median mode. All are equal. This is normally distributed. अब इसमें जो है इसका स्टैटिस्टिक किस तरीके से है, बैंड 1 के लिए कितना है मिनिमम मैक्सिमम 1 पिक्सल के लिए यहाँ पे, और उस बैंड में कितना है स्टैंडर्ड डिवीजन कितनी है, ये कलर का, इस तरीके से. दैट इज द इमेज क्लासिफिकेशन. इमेज प्री प्रोसेसिंग क्या करते हैं, create a more accurate representation through geometric correction, radiometric correction and atmospheric correction. क्या होता है तीनों भी बता चुके हैं. Can also make it easier to interpret using image enhancement. Image can be ordered at different levels of correction and enhancement. Rectification, remove distortion, platform, sensor, earth atmosphere. Radiometric correction क्या होता है, de-stripping and noise removal. Radiometric correction is pre-processing method to reconstruct physically calibrated value by correcting the spectral errors and distortion caused by sensors. These are the radiometric correction after before correction and after correction. Figure shows a typical system errors with results in a missing or defective data along scan line. Draw values line are normally corrected by replacing the line with the pixel values in the line above or below, or with the average of the two. Speckle noise and removal before and after, you can see. Come to the geometric correction. Geometric correction include correcting for geometric distortions due to sensor or geometric variation and conversions of data to real world coordinates, example latitude and longitude. The systematic to predictable distortion can be corrected by accurate modeling of the sensor and platform motion by geometric relationship of the platform with the earth. Therefore, to correct other unsystematic or random errors, we have to perform the reference of the image to a known ground coordinate system using ground control points. These are the geometric crosses, systematic distortions, how the distortions are occur, roll variation, yaw variation, spacecraft velocity, earth rotation, altitude variation, pitch variation. Atmospheric correction कैसे करते हैं? Solar radiation is largely unaffected as it travels through the vacuum of the space. However, when it interacts with the Earth's atmosphere, it is selectively scattered and absorbed. The sum of these two forms of the energy loss is called atmospheric attenuation. The general goal of atmospheric correction is to turn the digital brightness value recorded by remote sensing system into scaled surface reflected value. These values can then be compared or used in conjunction with scaled surface reflected values obtained anywhere else on the planet. Atmospheric scattering, absorption, reflection. Yeah, the एक सिंपल ज्योमेट्री बताई गई है कि एटमॉस्फेरिक करेक्शन, एटमॉस्फेरिक डिस्टॉर्शन होता कैसे है. There are several ways to atmospheric correct remotely sensed data. Some are relatively straightforward, while others are complex, being formed by the physical principle and requiring a significant amount of information of the function property. After atmospheric correction, these are the before atmospheric correction. You can just see how much the images are clear. Pixels are clear. इमेज इन्हांसमेंट कैसे करते हैं, यहाँ पे थोड़ा सा दे लेते हैं, फिर शुरू करते हैं. आप फिर से इमेज इन्हांसमेंट improves interpretability of the image by increasing apparent contrast among various features. Contrast manipulation, contrast stretching, spatial feature manipulation, spatial filtering, edge enhancement and Fourier analysis, multi-image manipulation, band ratioing, principal components, vegetation indices. These are the image enhancement property after the stretching. Original image after stretching the image are much clearer than the before. Image enhancement, contrast stretching. Just see how the images are clear after the contrast stretching. Histogram property, DR sensor, DR display, DR sensor and DR display. These are the pixel value 0 to linear stretch, that is this. These are the images value, DN value after the images stretch. Here the histogram after this spatial stretching. We see low contrast, normal contrast, pictures are more clear. Histogram visual equalization. After the equalization, histogram equalization, the pictures are much more clear than the before. Spatial feature enhancement, local operation. Spatial filtering convolution, low pass filter, emphasizing regional spatial trend, de-emphasizing local variability. This is a property of low pass filter. High pass filter emphasizes local spatial and variability. Edge enhancement combines both filters to sharpen each image. लो पास फिल्टर की ये जो स्पेशल प्रॉपर्टी होती है कि एम्फसाइज रीजनल स्पेशियल ट्रेंड्स को करता है, और हाई पास फिल्टर में ये होता है कि एम्फसाइज लोकल स्पेशियल वेरिएबिलिटी करता है. एज एनहेंसमेंट होता है कंबाइंस बोथ फिल्टर्स टू शार्पन एज इन इमेजेस, दैट इज द लोकल ऑपरेशन. Variation in a digital number along a line, an image can be expressed as a range of sine waves with different amplitude and frequencies. Their comparative effects in the same as the real frequency and distribution of the image. Convolution matrix of a low pass filters. Just see a central pixel. Convolution matrices is detection or high pass filtering can be achieved by separating the results of the low pass combination from the original image or by devising matrices based on the more complex algorithms. Just see for this mathematics, you can check in very you can check just pause the video and you can check for this for these pixel values matrices. और अगर इसके लिए आपको करें तो एक सेपरेट वीडियो बनाना पड़ेगा, लेकिन फॉर sake of a knowledge you can see this. High pass filter image in the convolution matrix is 11 to 11 pixel. We'll put this image northward direction matrix in the southwest direction. Directional filtering from a different direction tends to enhance or disclose linear features that lie preferentially near the perpendicular to the traverse direction. In the image below, the array was moved diagonally across the scene. Multivariate image statistics. In remote sensing, it is often concerned with the measurement of how much radiant flux is reflected or emitted from an object in more than one band. It is useful to compute multivariate statistical measures such as covariance and correlation among the several bands to determine how the measurements co-vary. Band ratio principal component analysis. This is the multi-statistical analysis. Feature section, classification and accuracy assessment. Just take a small break. Okay, after break, multi-image statistics देखते हैं. Remote sensing is often concerned with the measurement of how radiant flux is reflected or emitted from an object in more than one band. It is useful to compute multivariate statistical measures such as covariance and correlation among the several bands to determine how the measurements to co-vary. Band ratio principal component analysis, that is the multi-statistical analysis. Feature selection, classification and accuracy assessment. Band ratioing. The ratio of two bands removes much of the effect of illumination in the analysis of spectral differences. This is possible because the composition difference between two geological units, say here limestone, which is grey white in RGB 3:1, and red which is red in RGB 3:1, determine the ratio of any two bands where the illumination determines the magnitude of the digital number DN value received by the satellite. However, in areas with the significant haze, the performance of ratioing is much improved by the remove the haze produced by the relay scattering in the atmosphere. I hope this is well explained, and this is the two ratio of the two bands. ऐसे shadow effect और जो less illumination area को ज़्यादा enhance हो जाता है. This is the before correction and after correction, that is band ratioing. Blue radiation shows the strong topography because of difference of illumination. Thematicness, part of Egypt. The ratio band 3 and band 2 removes much of the effect of illumination and differences in rock type. These two other ratios of 5/2 and 7/4 after characteristic of the rocks and all the RGB images simultaneously. Band 7 is good at showing hydroxyl common in hydrothermally altered rocks, and band 5 good for iron oxides. Near infrared minus red divided by near infrared plus red. अब आगे important is normalized difference vegetation index (NDVI), used to map global primary production and is computed as near infrared minus red divided by near infrared plus red. What is NDVI? A simple answer, health of vegetation. तो NDVI से क्या पता चलता है? इसका हेल्थ का, वेजिटेशन का हेल्थ पता चलता है। तो इसका जो NDVI का अगर फॉर्मूला की बात करें तो नियर इंफ्रारेड का स्पेक्ट्रम माइनस रेड का वेवलेंथ एंड डिवाइडेड बाय नियर इंफ्रारेड प्लस रेड का, वेयर इंक्रीजेज रेड सोर्स स्ट्रेस vegetation and vegetation near infrared source chlorophyll. रेड सोर्स स्ट्रेस वेजिटेशन एंड वेजिटेशन नियर इंफ्रारेड सोर्स क्लोरोफिल। तो यानी कि नियर अगर इंफ्रारेड के रेस में कर रहा है तो इसका मतलब कि क्लोरोफिल है, रेड की तरफ शिफ्ट कर रहा है तो इसका मतलब कि आपका वो है, क्या कहते हैं, वेजिटेशन में स्ट्रेस है, मतलब पत्ती उत्ती सूख रही है। और इसकी वैल्यू 1 to -1 होती है। नियर इंफ्रारेड विजिबल 0.72, वैल्यू अगर 1 के करीब है तो वेजिटेशन हेल्दी वेजिटेशन को, और अगर ये लेस देन जा रहा है तो वेजिटेशन थोड़ा पुअर है, मतलब कि वहाँ पे अच्छा नहीं है। एवरेज NDVI of October 2003, June 2003, these are some pictures. Because of band correlation, what one see in band 1 is not so much different from what one see in band 2. This is the PC analysis. As per linear algebra, we are making eigenvectors where the eigenvalues contain the contribution of each band to the principal components. 6 principal components for bands 1 to 5, 7 of an Landsat thematic image. Band 1, band 2, band 3, band 4, band 5 and band 6. And this is a correlation matrix and correlation eigenvectors. PCA1, PCA2, PCA3 and PCA4. PC एनालिसिस को इस तरीके से समझ सकते हैं कि सपोज दैट यू आर स्टैंडिंग ऑन सी, एक नाव में है और आप सी के बीचों बीच बैठे हैं, तो आपको चारों तरफ पानी ही पानी दिखेगा, दैट इज़ योर वन व्यू। और अगर बीच पे एक आदमी खड़ा है तो उसे दो चीज़ दिखेगा, एक पानी दिखेगा और दूसरा ये दिखेगा कि पानी है और दूसरा बीच है। अगर व्यू का ओरिएंटेशन को रोटेट कर दिया जाए तो ऑब्जर्वेशन भी हमारे डिफरेंट हो गए। तो पीसी एनालिसिस ये करता है कि इसमें रोटेशन, डेटा सेट को बिना चेंज किए इसमें रोटेशन कर देते हैं विद यूनिट वेक्टर, और किसी चीज़ में यूनिट वेक्टर से मल्टीप्लाई करें तो डेटा सेट में कोई अंतर नहीं आता। लेकिन ऑब्जर्वेशन जो हमारा है डिफरेंट, जैसे कि इसमें यहाँ पे किया गया है पीसी एनालिसिस में, तो ये डिफरेंट होता है। In most images, the radiation of the receive in one wavelength is strongly correlated to the radiation among the in most other bands. Bright is bright across the spectrum, as is dark. We see color or spectral differentiation in infrared when radiation varies from the correlation line. Band correlation produces image without much contrast. To eliminate the paisley colored images, we remove the correlation in SCI, HIS, and CI space. Here image color box for the image classification, RGB image after DCS in RGB color space. और इसको समझने के लिए एक सेपरेट पूरा लेक्चर वीडियो लेना होगा, पर इंफॉर्मेशन के लिए आप जान सकते हैं, इसे देख लीजिए। RGB इमेज, डेकोरेटेबल इमेज क्लासिफिकेशन पे आते हैं। दिस इज द सीन्स ऑफ द टर्निंग रिमोट सेंसिंग डाटा इनटू मीनिंगफुल कैटेगरीज रिप्रेजेंटेड सरफेस कंडीशन और क्लासेस फीचर एक्सट्रैक्शन। स्पेक्ट्रल पैटर्न रिकॉग्निशन procedure classifies as a pixel based on its pattern of radiance measurements in each band, more common and easy to use. Spectral pattern recognition classifies a pixel based on its relationship to surrounding pixel, more complex and difficult to implement. Temporal pattern recognition looks at changes in pixel over time to assist in feature recognition. Purposes of image classification: geologic terrains, mineral exploration, alteration mapping, land use and land cover, vegetation types, spectral classification, two types of classification techniques. Supervised, prior knowledge of class, tell the computer what to look for. Unsupervised, let the computer look for the natural cluster, then try to classify those based on the posterior interpretation. तो स्पेक्ट्रल क्लासिफिकेशन में दो आता है, एक सुपरवाइज है अनसुपरवाइज। ये सिर्फ रिमोट सेंसिंग में नहीं, बहुत से पैटर्न में इसका यूज होता है। अगर सुपरवाइज को अगर जनरल टर्म में समझे कि क्या है, कि सपोज दैट यू आर गोइंग इन ए मार्केट फॉर बाई बनाना, तो बनाना आपको पता है भाई कि 40 रुपये दर्जन मिल रहा है, 40 रुपीज़ फॉर 1 डजन, तो आपको ठग नहीं सकता है, वो 40 रुपीज़ में ही देगा। आप सीधे कहेंगे कि ये तो 40 में मिल रहा है, क्यों ऐसा कर रहे हो, तो दूसरी दुकान पे लेंगे, तो आप वहाँ पे नहीं। सपोज दैट यू आर गोइंग इन ए अननोन मार्केट, वहाँ पे आपको पता नहीं है सेम बनाना खरीदने के लिए। मान लीजिए आप किसी ऐसी जगह गए जहाँ बनाना की ज़्यादा फसल ना होती हो, इस तरीके का, तो वहाँ पे आपको दाम नहीं पता है, तो वहाँ पे हो सकता है ज़्यादा हो या कम हो, तो वो जो बताएगा वो आपको मतलब मानना पड़ेगा। अगर वो कहता है 20 रुपया, तो आप बहुत खुश हो जाएंगे। हो सकता है एक्चुअली वहाँ दाम 10 रुपया हो, या फिर वो 50 रुपया वहाँ जाता है, तो भी आपको ज़्यादा, आप उसमें ज़्यादा बदल नहीं कर सकते हैं। तो इसी तरीके का होता है कि जो हेडर फाइल अगर आप दे रहे हैं यहाँ पे सुपरवाइज में, तो उसका नॉलेज है, लेकिन अनसुपरवाइज में कंप्यूटर आपको खुद हेडर फाइल निकाल करके देता है। अब एक और होता है इसमें स्पेक्ट्रल क्लासिफिकेशन में, रेनफोर्समेंट लर्निंग। सपोज कि आपको किसी ऐसी जगह पर उतार दिया गया, किसी आइलैंड पे, कि वहाँ पे आपको कुछ पता ही नहीं है कि मतलब कि किस डायरेक्शन में क्या मिलेगा, तो आप वहाँ पे तो पहले तो सर्वाइव करने की सोचेंगे, फिर कुछ दिन घूमेंगे, फिर नारियल पेड़ है तो भाई वो देखेंगे, इसी तरह जिएंगे। मतलब कि एक स्ट्रगल कर रहे, खुद से सीख करके जिए। तो जब कंप्यूटर कुछ भी नहीं पता होता है आपको, आप कुछ डेटा सेट डाल दिए, उसका डेटा सेट को उसने समझा, एनालिसिस किया, फिर उसमें जान डाला, और जान डाल के कुछ रिजल्ट दिया, दैट इज़ द रेनफोर्समेंट लर्निंग। और ये जो मशीन लर्निंग का पार्ट है, आर्टिफिशियल इंटेलिजेंस, डीप लर्निंग, वो सब उसमें आता है। आई होप द सुपरवाइज एंड अनसुपरवाइज क्लासिफिकेशन जनरल टर्म में समझ में अच्छे से आ गया होगा। Better for cases where the validity of classification depends on a prior knowledge of the technician already known about what types you plan to classify. Conventional cover classes are recognized in the scene from prior knowledge or other map layers. Training sites are chosen for each of these classes. Each training site's class results in a cloud points in a dimensional measurement space representing variability of different pixel spectral signature in that class. And supervised classification में algorithm क्या यूज होता है, minimum distance to mean classification, chain Gaussian maximum likelihood classification, paralleloid classification. Each will give a slightly different results. The simpler method is the minimum distance, in which a theoretical center point of point cloud is plotted based on mean values, and an unknown point is assigned to the nearest of these. That point is then assigned that over class. Different method of spectral classification can be represented diagrammatically by reference to bivariate plots. This is the part of the research. Maximum likelihood, the contour express the probability that any point belongs to a particular class, which is the basis for the maximum likelihood method of the classification. Supervised classification, pre-chosen training sites for the known cover type, Morrow Bay Band 1, Idrisi Composite. Supervised classification here source. The next step is the computers to assign each pixel to a spectral class it appears to belong to based on the DNs of its constituent bands. Clustering algorithm look at clouds of pixels in spectral measurements from training areas to determine which cloud a given non-training pixel falls in. Supervised classification example of two classifiers. अनसुपरवाइज क्लासिफिकेशन पे आ गए, जैसे कि अज्यूम नो प्रियर नॉलेज, जैसे कि आपको केले के मार्केट में गए, अकेले का दाम पता है नहीं. Computer groups all pixels according to their spectral relationships at looks for natural clusterings. Assume that the data in a different cover class will not belong to the same grouping. Once created, that the analyst assess their utility and can adjust clustering parameters. After comparing the reclassified image based on the spectral classes to group ground reference data, the analyst can determine which land cover type the spectral class corresponds to. Has advantage over supervised classification. The classifier identifies the distinct spectral classes, many of which would not have been apparent in supervised classification, and if there were many classes, would have been difficult to train all of them. Not required to make assumptions of what all cover classes are before classification. Clustering include k-means, texture analysis, unsupervised spectral classification. This is the image. Slicing, density slicing, gray level DN value distributed along the axis of an image histogram are divided into a series of analyzed specified intervals. All DNs mean digital number falling within a given interval are displayed at a single DN in the output images. The process of converting the continuous gray tone of image into a series of density interval or slices, each corresponding to specific digital ranges. Example of density slicing. Thermal imaging क्या होता है भाई देख लेते हैं. All matters which are having temperatures above absolute zero of Earth radiate energy at a thermal infrared wavelength 3 to 15 micron day and night. Many multi-spectrum systems sense radiation in the thermal infrared as well as visible and reflected infrared portions of the spectrum. However, remote sensing of energy emitted from the Earth's space in the thermal infrared is different than the sensing of reflected energy. Thermal sensors use photodetectors sensitive to the direct contact of photons on their surface to detect emitted thermal radiation. The detectors are cooled to temperatures close to the absolute zero in order to limit their own thermal emission. Thermal process and properties. Thermal sensor essentially measures the surface temperature and thermal properties of targets. Thermal infrared images generally record broad spectral bands, typically to 14 micrometers for images from aircraft and 10.5 to 12.5 micrometers from satellites. To interpret the thermal infrared images, one must understand the basic physical processes that control the interaction between the thermal energy and matter, as well as the thermal properties of the matter that determine the rate and intensity of the interaction. Heat, temperature, and radiant flux. Kinetic heat is the energy of particles of matter in a random motion. The random motion causes particles to collide, resulting in change of energy state and the emission of electromagnetic radiation from the surface of materials. The internal or kinetic heat energy of matter is thus converted into radiant energy. The amount of heat is measured in calories. Temperature is a measure of current concentration of heat. On the Kelvin or absolute temperature scale, 0K is absolute zero, the point at which all molecule motion ceases. तो absolute zero पे सारे molecules का जो motion होता है वो वाइब्रेशन वो रुक जाता है, लेकिन ऐसा मतलब आइडियल केस में ही हो सकता है, जो कि पॉसिबल नहीं है. हीट, टेम्परेचर एंड रेडियंट फ्लक्स. हीट, टेम्परेचर एंड रेडियंट फ्लक्स. The electromagnetic energy radiant from a source is called a radiant flux and is measured in a watt per square centimeter. The concentration of kinetic heat of material is called a kinematic temperature and is measured with a thermometer placed in a direct contact with the material. The concentration of a radiant flux of a body is radiant temperature. The radiant temperature of material is always less than the kinematic temperature because of a thermal property called emissivity. Heat transfer. Heat energy transferred from one place to another by three means: conduction, transfer heat through a material by molecular contact, say heat transfer from pan to vegetable using cooking. Convection, transfer of heat through the physical movement of heated matter. The circulation of heated water and air are the example of convection. And radiation, transfer heat in the form of electromagnetic waves. Heat from the sun reaches the earth by radiation. Radiation can transfer heat through vacuum. Materials of the heat at the surface of the earth receive thermal energy primarily in the form of radiation from the sun. To a much lesser extent, heat is also conducted from the interior of the earth. Energy from the interior of the earth reaches the surface primarily of conduction. Hot springs and volcanoes are local sources of convective heat. Regional heat flow pattern may be altered by geologic features such as salt domes and faults. Atmospheric the infrared region of the thermal conductor in its atmospheric window of 3 to 5 and 10.5 to 5 micrometer. इसको तो देख ही चुके हैं ज़्यादा. इसमें फर्स्ट में रेडिएंट एनर्जी है, दैट इज द radiant energy comes for the object different Rayleigh energy spectrum. For object and constant current temperature, radiant flux, radiant energy visible, that is the more energy, and less energy is for below the red color, red spectrum. Wavelength micrometer. वेवलेंथ अगर कम है तो एनर्जी इसकी ज़्यादा रहेगी. स्पेक्ट्रल रेडिएंट इमिटेंस, जस्ट सी हियर, सन का यहाँ पे है. तो यहीं पे थोड़ा स्टॉप करते हैं और फिर अगला सेशन लेंगे क्योंकि रात काफ़ी हो गई है, और फिर अगला सेशन कल लेंगे और इसके बाद से फिर देखते हैं. और अगर इस वीडियो को आप लोग देख रहे थे प्लीज़ लाइक और शेयर और सब्सक्राइब करिए, कम से कम लाइक तो करिए.